Now, something that you can do that's kind of cool, sorta, maybe, is you can go into y equals right here. And I can clear this out. I don't want you to get caught up in this stuff just yet. We'll get there long enough. Let me get it back to where you're going to be. Okay. So what I can do now is I can type in my 5.83x. My calculator doesn't have a, hold on. And then do plus 1416.67. And then what I can do is kind of cool. I can go to my window to set it up to where it makes sense for my problem. Now, guys, remember in our window here, x is the number, right? And in our problem, the numbers were 100 and 700. So I need to set it up something that kind of makes sense to my problem. So I'm going to go from 100 up to about 1,000. Okay, that includes my 100 and my 700. And in this problem, my y's represent my cost. Well, my cost ranges from 2,000 to 5,500. So I'm going to let the cost go from a little bit below 2,000. I may start at, say, 1,000. And do my cost maybe at 6,000, something above the biggest. Okay, hit graph. And I see the graph of the line. Now, just to give you an indication that what we're doing does make sense, well, I don't know if it makes sense or not. Right here, there's a calc button. So I can go second function calc and go value. And it allows me to come up with a function value given a particular x value. So when I put in 100 there, within, kind of accepted rounding errors, I should get something very close to what? Well, when x is 100, the cost is 2,000. So I should get something very, very, very close to 2,000, and you see I do. Now, the reason it's not perfect is this 5.83 was not my slope. My slope was 5.833333 on and on and on. But the problem said round to the nearest hundredths, and that's what we did. The intercept is not 1416.67. It was 1416.666666, on and on. So that's why we're off a little bit here. Guys, we can do that again. Go second function calc, go value. And when we put in 700, we should get something very close to 5,500, which we do. Okay, now let's go ahead and work this. So what is the value of the slope? That's going to be 5.83. Interpret its value in the context of the problem. It would be the additional cost. Per unit produced. Now, next thing is what is another name for the slope when we have a cost function? Well, guys, we got two things. We can call this the marginal cost or variable cost. What is the value of the intercept? $1416.67. Interpret its value in the context of the problem. Guys, the intercept is always the value when our x, or in this case n, is equal to 0. So this says that c of 0 is 1416.67. This tells us when we create no quantity, no widgets, that the cost of producing 0 widgets is $1,416.67. My daughters, one time they went by and saw me teaching like this, and they're like, "Daddy, you don't write real well." I said, and I'm like, "Well, yeah, I guess not." But they said, "I bet you write better when you're in the classroom on the chalkboard." No, I don't. Doesn't get any better. All right, where are we here? I've lost my. Okay, E. What is another name of the intercept when we have a cost function? Well, guys, should make sense. The fixed cost. So when what fixed cost is just what it costs to open the doors. It's before you produce the first widget. So for this fictional company here producing these widgets, it's going to cost $1,416.67 to open the door every morning. And for each additional widget, it's going to cost $5.83 manufacturing cost. So now, what will be the cost of producing 1,250 widgets? Guys, I'm going to use the calculator just because I do. So I'm going to calculate. I'm going to go to value. I'm going to type in 1,250. And it doesn't work. Now, what happened there? Well, what happened was, and actually, I'm glad this happened. We didn't, well, I didn't set my range big enough to work this problem. Okay, so I'm going to hit go to, and it's usually going to take me where I have a problem. And let me show you what's going on there. If I go back to window, I can only work problems from 0 to 1,000, and really that's all I needed to do. I don't know why the thing keeps narrowing. That's all I needed to do because I had 100 widgets and 700 widgets. This 0 to 1,000 right here took care of what I had. But now for some reason I want to come in and figure out 1,250. So I need to go high enough to where 1,250 is included. So I'm just going to be safe and go out there around 2,000. All right, so now I'm going to graph. I'm going to go second function calc. Value, type in 1,250. And I'm going to get my value of 8704.17. Okay. Now, I said something in my introductory video that I think that this online learning has a lot of places where it's really advantageous. This is one of those places. It really is. This is one of those places where I think it's better to learn this online than it is in the classroom, because when I'm doing all the calculator stuff, if you're not getting it, you can rewind the video. If you don't get it in class, you can't rewind me. And some students don't feel comfortable speaking up in class and telling their professor to slow down. You've always got the potential to tell me to slow down in this video, because you can stop me, rewind me, and do things over. Okay? All right, gang. Let's get into another type of problem here. And guys, I'll tell you, part number 2, you're going to... I was going to tell you, you're going to have one of these on your first exam, so get ready for it. So the cost of making 100 items is $3,000, and the cost of making 150 items is $3,300. The relationship between quantity and cost is linear. So what I'm thinking about here is I'm going to create a function, C of Q, which is the cost as function of Q, which is our quantity. So I've got a quantity of 100 items. I've got a quantity of 150 items. So gang, let's set the problem up. Let's learn from what we've done previously and make it make this type of problem easier. So guys, I know that C of 100, let me get this where you can see it. All right, so C of 100 equals 3,000. And C of 500, or I'm sorry, 150. I'm just making up stuff. It's 3,300. Now, what did we do before? Well, we said we can make ordered pairs. Like this. What did we do next? We use the calculator. Now, a lot of times I have students who are like, Dr. Darber, I just don't want to use the calculator. I want to do this by hand. Hey, you know what? Go for it. Go do it. And we'll be done with the problem. You'll still be back there farting around finding slopes, and we'll be doing cool stuff. No, I'm just joking. I'm being facetious here, being goofy. You know, if that's what you like, and I do. I think every single student should be able to take a two-ordered pair and be able to find the equation of a linear function that passes through them. But in an applied course like this, you know, it's kind of like my wife. She's a really good cook, and if she's in the kitchen and she wants to add 2/3 and 5/8, well, I've taught her how to do it on the calculator. Now, as someone who's 2 years away from her PhD in school psychology, should she be able to add those fractions? Yes, probably. But you know what? She's done just fine without doing it that way. In fact, she's done really well. She's at the top of her profession. So she's done excellent. So I'm running my mouth, guys. I'm just going crazy here. So let's do some stuff. So we have 100 and we have 150. And the associated cost for those items is 3,000 and 3,300. All right, so what did we do before? We went second quit. We went to stat. We went over to calc, down to number 4. Left, second, 1, comma, second, 2, right parentheses. And again, guys, right down here, you've got L1, you've got L2 that can be accessed by hitting the blue key first. And right there is your comma key. Now, what we got here on the calculator is we have the y equals 6x plus 2,400. Guys with me? Put the 6 in for A, the 2,400 in for B. And we got our answer, right? Well, sorta. But that's not what we want. That's the generic using y's and x's. What we want is the cost as a function of quantity. So what's naturally going to take care of this? C of Q. Plus 2,400, or C of Q equals 6Q plus 2,400. Replace X with Q, replace Y with F of X, which is C of Q in this situation. See, guys, math doesn't have to be hard. We just like to make it hard. So our cost function will be C of Q equals 6Q plus 2,400. I didn't leave myself much room to write here. What's the fixed cost? 2,400. What's the marginal cost? $6. It's the slope. Interpret in your own words what the marginal cost tells you. It tells you that the cost to produce an additional item is $6. I don't ask you to do this, but if the fixed cost $2,400, that's what it costs to open the doors. So from this, we know that C of 0 is 2,400. Before we produce the first unit, we are looking at a $2,400 cost. So I know that C of 1 is going to be what? Without even doing any plug and chug. Well, it's going to be $6 more than I started out the day with my cost. So guys, without even thinking, I know that C of 1 is going to be 2,406 because I've produced one additional item going from 0 to 1. Okay? So marginal cost, we've gone over that. Now, part E, if the item is sold for $9.50, what's the revenue function? Well, guys, we run into revenue function a lot in this class. And revenue function is actually one of the easier things. Well, I've run out of paper. It's one of the easier things. But it's one of the things that students seem to mess up the most. Okay, in our revenue function, it would make sense if we call our cost function C of Q. We would call our revenue function R of Q. Guys, your R of Q is going to be the price that you sell the unit at times the quantity. When I was in the golf business, if I sold drivers for $300, then my P was 300. If I sold 5 of those in a day, I could take 5 times 300 to get 1,500. That would be my revenue when I sold a quantity of 5 drivers. Guys, don't put stuff out here like you do in the cost function. The revenue function is simple. It's the price you sell it at times the number of the quantity. So, guys, taking that very, very simple concept, if something is sold for $9.50, what's our revenue function? Let's call it R of Q for revenue. The price is $9.50 times Q. Now, I'll tell you something I see a lot on exams, and this is a no-no. I see students get sloppy and just put that. They don't use the Q. Well, what that tells you is that the revenue is never changing. It's always $9.50, and it doesn't vary according to the quantity. It's a constant. If you have a quantity of 10 or 10 million, your revenue is $9.50. That makes no sense. Revenue has to vary according to the quantity. So guys, just from teaching this class a lot, always make sure you put the Q there. Tell you what, I need to run and get more paper. I'm going through paper like crazy. Give me 30 seconds. All right, guys. Now, the next question we get into, this crazy is going to drive me insane. All right. The next question we get into is how many items must be sold to break even. And let's do some kind of teaching moment here, okay? Break even very, very simple. As you would think, that is where your cost and your revenue are equal. Or it's where your cost minus your revenue is equal to 0, which is equivalent to the revenue minus the cost being equal to 0. We typically work with this one because when we open a business, we hope that our revenue is going to be more than our cost so we can make money. But this is another form that is perfectly equivalent and okay to work with. So I'm going to demonstrate this problem with this form. So gang, we saw that our cost function in this problem was 6 cubed plus 2400. We saw that our revenue function was 9.5 Q, right? Yeah. Subtract 6Q from both sides. That should make sense. Divide both sides by 3.5. So gang, I'm going to put this in my calculator. So I have 2400 divided by 3.5. I get 685.7142857. Can't have partial quantity in these objects, so it's going to take 686 units. I always round that up to the next value, and that's pretty common to do that. Okay. Now, how many items? So how many items must be sold to break even? This is going to be 686. Now, next question there is how many items must be sold to realize a profit of 100,000? Now, we got another function that we run into in Math 1700. So let's think about what we've got so far. In 1700, we run into a cost function, which is a number times Q plus another number. This is our marginal cost. And this is our fixed cost. Another thing we've run into is R of Q. And that's a value times Q. What goes in that box? The price. Guys, we can combine these two things and get a profit function, which should be clear that we would call it P of Q, called revenue function R of Q, cost function C of Q. We call our profit function P of Q, and our profit function is just the revenue minus the cost. Now we saw earlier if our profit is equal to 0, then we have a break-even point. So when this is equal to 0, we can solve for R of Q minus C of Q. Now for our problem, our profit function is going to be what? It's going to be our revenue function minus our cost function And you know what? That looks so right, and it is so wrong. If you wake up wanting to do a problem wrong, do that. Now, what have I done? Guys, this minus right here, the subtraction, says that we want to subtract the entire cost function. This notation right here, I've gotten sloppy, and I did this intentionally because it's a mistake that students make quite often. This is only subtracting the 6Q. It's not affecting the 2400. That negative sign has to affect the entire cost function. So this is just going to require that we do another step, distribute the negative through, and we simplify to make 3.5Q minus 2400. Now this particular problem here wants us to realize a profit of 100,000. So this should be pretty easy now. So we want our profit. So we know that our profit function is 3.5Q minus 2,500. So we want our profit to be 100,000. So we should know now, I add 2,400 to both sides. So we get 102,400 equal 3.5Q. So Q is equal to looks like a lot of units. 29,258 units. So it's going to take a lot of units to create, I think these were daily production. This is a daily production schedule. So it would take 29,258 units to break even, given this. No, I'm sorry, not to break even, to realize a profit of 100,000. So a Q would be 29,258. All right, guys, got one more problem for you, and this video will be done. So changing things up a little bit here. Going to go the other way. So a piece of equipment costs $10,000 when purchased new. After 10 years, the trade-in value is $3,800. The rate of depreciation per year is constant. Guys, this information right here just tells you that the rate is linear, which means you're going to use the principles of y equals mx plus b. All right? So gang, you tell me, what are we going to do here? Just like we did before, right? We know that we have a function v of t, where t is the number of years after it was purchased. So we know that t of 0, when it was purchased new, is 10,000. We know that t of 10 years later, 3,800. What have we done before? Created ordered pairs. $10,3,800. What did we do after that? Grab your calculator. Well, I just lost my mind. Okay. Guys, my batteries are going bad, and it keeps kicking off. I just hope I get through. Oh, wow. All right, gang, let me go get a calculator. All right. Between the UPS man, the dogs, my daughters tell me all the time, it's like, Daddy, you sure do have a lot of calculators. So yeah, I do. All right. Let's get this going. So just like before, now this is a new calculator, so I'm going to have to clear out some things. So that's kind of cool. Go up and hit clear enter, and go over and hit clear enter. So when x was 0, or in this case t was 0, that was 1, then we had information 10 years later. We know when we had a 0, we had a initial value for this problem of 10,000, and we had a 3,800. All right, what do we do next? Second, quit. What do we do next? Stat. Go over to calc. Go down to number 4. Left parentheses, blue 1, comma, blue 2, right parentheses. That was too fast for you. Left parentheses, blue 1, comma, blue 2, right parentheses. All right? Now, we got some extra stuff here, and that's fine. It's not a big deal. But we see that our slope, which goes, in this case, A, is negative 620. And our B, as we would expect, will be 10,000 because that's what we started with. All right? So the answer to part A is our value as a function of t is negative 620t plus 10,000. Now you should have known that this value right here was going to be 10,000 because by definition this is the value when t is equal to 0, and we just happen to have an order pair here that provided that to us. So that part was pretty clear. And this part here, the 620, you think about back, just kind of using this as a teaching moment, you think about this back as the slope formula. It takes the difference in the y's, y2 minus y1 over x2 minus x1. So if you take this, you get 3,800 minus 10,000. Which is minus 6,200 over 10, gives you negative 620, just as we got. Okay, sorry about that. I just wanted to make a point. Find and interpret V12. I'm going to plug and chug on this one just to show you a different way. So V12 is going to be negative 620 times 12. So we'll put that in our calculator. So $2,560. So we've done part of that. It said find. Well, we did. We found it. And now we want to interpret it. And this is the value of the equipment. "12 years after it's purchased." All right, gang, last problem. We're about done. How much does the equipment depreciate per year? Well, gang, that's exactly the interpretation of the slope. It's going to be tempting to put negative 620 there. It doesn't depreciate negative 620. It goes down 620. So that's the depreciation value of $620 per year. Depreciate indicates we've got a negative. So it's going to be tempting to put that negative there, but you don't put the negative there because if it's something depreciates a negative value, it actually goes up. Depreciate means you have an implied negative. Gang, that's all I got. This is pretty much what you're gonna be living with for the next 9 weeks. I think it's a very effective way to teach this because it gives you a lot of flexibility on stopping some of the calculator stuff and going back and watching stuff if you need to. So I think it's an extremely effective way to teach this part of the class. So guys, take care.